At this point in your chemistry careers, you know that moles represents a number of particles. You know that it's very similar to the idea of a dozen. So if I were to tell you how many dozen of something I had, you would have no problem telling me how many individual items there are, because you know that there's 12 in every dozen. Similarly, if I were to tell you how many moles of something you had, you would have no problem telling me how many individual particles we have, because you know how many particles are in a mole. Now, we're probably not going to be calculating how many particles total there are anymore, because that's not all that useful. It's much more useful to bundle them together in moles and just talk about them that way, because that gives us smaller numbers to talk about. Now, you also know that in a balanced chemical equation, the coefficients represents number of particles. So what we want to do next is take that coefficients and relate that to moles and be able to use the balanced chemical equation to get from moles of one substance to moles of another substance in the equation. So let me show you what I'm talking about. Let's look at this chemical equation right here. So we've got N2H4 plus 2H2O2 yields N2 plus 4H2O. So what you can tell from this balanced chemical equation is that in the process of doing the reaction, there's a certain ratio of individual particles that goes on. It takes one of these particles and two of these particles to react together, and when they do that, they produce one of these particles and four of these particles. So what we're doing right now, when I say particles, I'm considering the entire water molecule to be one particle. So two hydrogens and an oxygen all bonded together. For our purposes right now, those are considered one particle. So we'll have four particles, if you will, of water, or four molecules of water. One molecule of N2. Now, as you know, there isn't any chemical equation that goes on that really just starts with one molecule and two molecules. Obviously, we're going to have a lot more than that, so that's what we want to get into today. So let's say, for example, that we knew that we were going to be able to start our reaction with 0.35 moles of N2H4. Now, if we know that, then we should be able to figure out how many moles of H2O2 are going to be required to react with that. We should also be able to figure out how many moles of each of these products we could get if they did that reaction, just by looking at the ratio of individual particles. So for example, we can see that these are in a ratio of 1 to 2. It takes two of these to react with one of these. So what we're going to do in terms of solving problems is to set up a ratio where we take, okay, here's the amount of N2H4 that I'm given in the problem, and what I want to solve for is, well, how many moles of H2O2 will I need to react with that? So we'll say, well, it takes 2 H2O2 for every 1 N2H4. So it takes two of these for every one of these. Now I've set this up, and I haven't written the word moles in there, but you could write it in there because that's really what I'm talking about. I'm just being a little bit lazy there. So moles of N2H4 are going to cancel top of the fraction, bottom of the fraction. I know I didn't write this as a fraction, but if you wanted to see it that way, you could just put it over 1. So these are going to cancel out, and we're going to end up multiplying this by 2, so that's going to be 0.70. And that will be moles of H2O2. Now, does that make sense? If I had 0.35 moles of this, would I expect to need 0.70 moles of this? Yeah, twice as much, because it's a 1 to 2 ratio. One of these requires two of these, so I would expect that I would need twice as much of this material. But this is the way mathematically you go about it, because sometimes you have problems that you can't do in your head like this. All right, so let's look at, given these amounts, 0.35 moles, so 0.35 moles of this, and 0.70 moles of this. So now let's look, if these two reacted, how many moles of each of these would we get? Well, hopefully at this point, if you're tracking with me, you would say, well, the coefficient here is the same as here. They're in a 1-to-1 ratio, so therefore I would expect 0.35 moles to be produced if this reaction happened. Now this one, we might as well just do the math, so for a little extra practice, though I'm sure you can do this in your head. I can start with any of these. It doesn't really matter which one I start with to do the math, but 0.35 moles of N2H4. Let's set up that ratio again. It's going to be 4 waters for every 1 N2H4. So my N2H4s are going to cancel. I need 4 times this amount, just 1.7. Sorry, I can't do math there, 1.4 moles of water. So we can write that in. So the ratio of this to this to this to this should be the same, if we've done it right, as the ratio of 1 to 2 to 1 to 4. And if you look at those numbers, I think you'll agree that that's true. So that's how you would go about figuring out how many moles of one thing you need, or how many moles of that would be produced, whatever the question asks for, if you're given something else in the problem. Now, let's look at this going backwards, just to make sure you understand you can go backwards. And by backwards, I mean I can start with something over here. Well, let's do that real quick, just so that you can see that happening. Let's say that the problem told me that I was interested in making, oh, let's make it really big this time, 35 moles of N2. So that's given in the problem, and they want to know, well, if that's the case, then how many moles of H2O2 would I be required to start with? So you do it the exact same way. It doesn't really matter that you're starting with something on this side of the equation, because we still got a ratio. It takes 2 of these to produce 1 of those. So I'd still set it up with the same kind of ratio that I did last time. So moles of N2 will cancel out, and I'm just going to multiply that by 2 and get 70 moles of H2O2. So you can work those backwards and forwards, and all you need to do is multiply by a ratio, and you should come out with the right answer.